Assalamualaikum warahmatullahi wabarakatuh. My name is Hanif. My metric number 2022905003 and I'm from class 4D. And today I'm going to present about citrus genetic engineering for disease resistant. For the first slide is the introduction. Citrus is one of the most important fruit crop and it's grown in more than 130 countries, predominantly in tropical and subtropical areas. The healthy progress of the citrus industry has been seriously affected by biotic and abiotic stresses. Several diseases such as canker and huanglongbing rigorously affect citrus plant growth, fruit quality and yield. For this presentation, I will explain about canker citrus. Citrus canker caused by the bacterial pathogen Xanthomonas citri sp. citri (XCC) is one of the most destructive citrus cultivar disease reported all over the world. Citrus canker affects citrus production, leading to yield loss and poor fruit quality, also trade barriers. We move to the next slide, which is the effect of canker on citrus. The effect is disease begin as a small pimple-like spot that are about 1 mm in diameter and yellow in color. As a spot enlarge, they become brown and corky with sunken centers and raised edges. Often each of these spots have a yellow ring surrounding them, as we can see the picture. The next slide is gene used to produce the transgenic crop, ATNPR1, which is a key positive regulator of the long-lasting broad-spectrum resistance known as a systemic acquired resistance. Our results indicate that overexpression of ATNPR1 in citrus increase resistance to citrus canker, and the resistance is related with the expression level of ATNPR1 in the transgenic plant. The line DG42-2 with the highest expression level of ATNPR1 was also the most resistant, which developed significant fever lesion accompanied by the 10-fold reduction in XCC populations. The lesion developed on DG42-2 were smaller and darker than those on the control and lacquer callus formation. This lesion phenotype resemble those on canker-resistant kumquat and canker-susceptible citrus tree treated with SAR-inducing compound. This overexpression of ATNPR1 in citrus is a promising proof for development of more resistant cultivar to citrus canker. And then the method used for gene transfer. First, the genetic transformation. We use a true polyethylene glycol, which is PEG, mediates direct DNA transfer. For the result, the genes that we use can increase fruit yield, improve forced harvest shelf life, reduce generation time, and produce of fruit with highest nutrition value. And for the last slide is the conclusion. Traditional breeding approach have shown difficulties in developing new citrus cultivar which better disease resistant due to the sum of the biological properties of citrus. As a result, genetic engineering, including transgenic or genome editing technologies, can be viable option for overcoming the limitation of traditional breeding and have enabled the protection of susceptible commercial cultivar against the pathogens, allowing for the release of improved cultivar with the desirable characteristic in a shortened time frame. And I think that's all from me, Hanif. Thank you.